I'm gonna leave out the M, maybe? Oh, what the hell, I can set M. The top M is the number of points, but that's just this. Need to calculate that. And I rewrite it. As WX, I think. Oh, damn it. This is, no. What? OP menu, this one is depending on T. And this one is not. What? Why? How? Oh, you are. Oh. Okay. I'll try to remember that. So it doesn't really look the same. So you are, how do you call that? Watching my every move, so you know what is this going, what this is about, right? So then I can discuss it with you. Man, I'm so confused. I thought, I mean, the loss function that I calculated was having this plus here. And then ChatGPT told me that normally people use a minus, so I tried that as well here for the L2. Both seem to go to a minimum, except that the mine is sometimes going to maximum, but well, if you put it upside down, it's still a minimum. And then I thought, well, let me go back to the basics and print the value that I base this all on. And then I get something that isn't even a function of t. This is definitely what I based it on. Definitely. So each point is unlikely. And so we sum up. Oh, this is still densities. That's why this is sigma. Yeah, I get it. I think that then there must be a bug indeed, or wait a minute, man. I mean, there's no minus sign here. Okay, let's start from this. Where's I running? Oh yeah, I is running over all points or all grid points. Is this still a grid? I went from grid points to density, I think. Let's see what I was. I runs over the distance, basically, I think. Yeah. Oh, that's late, man. Yeah, sleep well. Good night, as it were. Big green eye. I think this is a good start. I might have done something confusing now I think about it. I'm having sigma here, but one of them is a density and the other is the activation function. So definitely confusing, yeah. That's why I start here before I started to use sigmas, even though I just filled in this, but I'm going to reinterpret those four variables, I think, hopefully. So water, we have that, right? Although, no, I'm not sure anymore. That's a log of the likeliness. I want to have the L is the minus log of the likeliness, so this is the minus that where we run over I. And this is then a mistake-ish. Well, eventually I probably need it, but not yet. Let's keep it, I don't know. Have, what is it? What is P green I again? Why I end up here? Yeah, P green I. It's a sigma of that. Oh, here it is. P green I is the predicted probability that a point at xi is green. Let's copy that. Gonna copy the whole thing. Well, this still is the predicted probability. But I was doing the calculation for like 1 dimension, I think. So to generalize it here, we have, I keep doing that. I have this sigma and then, yeah. This must be just Wx. I want to keep using my dot, I think, because I do that everywhere. It's a totally different dot, but it finds my real dot. Amazing, isn't it? Oh. Okay. Oh. And there we just write it like that. Both work. Just, it's probably going to confuse the hell out of people. That in some cases I use the dot product, and in other cases I use a matrix multiplication. My code works with matrix multiplication, so I might as well. This is a dot product. Yeah. Let's add a comment in here. The first time I use Wx is here. Oh, that was just keep it for now. Remark. Thank you, Sentov. Also 3:30 a.m. here. There, I mean. Just same country as Abhimanyu. Yeah, making very slow progress. Can't make a remark here yet because it's not really part of my comments yet. But now it will be. Oh, because I'm filling it in here. Oh, I'm gonna keep working with the in product. Yeah, you should go to sleep, man. Good night. I'll see you tomorrow, maybe. Yeah, that's how I think about it. This is like the definition of my sigmoid output. Like literally. It is, the output of the sigma is the predicted probability. Yep, if it is on the line, then Wx is 0 and the sigma of 0 is a half. So on the line, the chance is 50% that it is red or green. This cannot be wrong. And then we have red. I'm not happy with running over I though. Let's do S. I have another comment that looks like this. I'm working with ZS really here. Oh, I have an X as well. I think I can work with the XS. So instead of I, we use the S, the sample. Much later I switched to samples, I think. Started off with a regular grid. And at some point I said, to hell with the grid. Let's use random samples. There's an S here. Whoop. My capital X is kind of a matrix of all the X's with columns that are the samples. So if I add an S here, then it's not really X. But let's tag it with an S. Okay, then obviously the chance that it is green is 1 minus that. That doesn't change. Chance that it is red, I mean. Doesn't even need a comment. So this is now the number of points at that distance. Well, we have only one. And it's only green when it is green, which means that it's T, right? TS. Might as well call it TS then. Is that confusing? Do I have a TS already somewhere in the comments? I do. We definitely have TS's here. Also talking about ZS, but this lowercase x, I don't want to start with that. Not for the vector that has lowercase x as element values. That would be too confusing, but okay, let's use a small t here. Nah, it's the addition. Let's do add. Only add this term if if it's a green point. I think I literally reinvented the binary cross, whatever ChatGPT called it. Because this formula is exactly that. Isn't it? At least I lost my minus sign. Okay, I'm dying in about 25 years or so. Log of p green as yeah, so one sigmoid is just still the sigmoid, but the other one is actually the predicted or the target. This one, it's no longer a sigmoid. Right, so I want to calculate my L as being the sum of something that depends on the target, because now it's either 0, this value is either 0 or 1, and they toggle, so either this one is 1 or that one is 1, aka we add either this or we add the other one, and that is scarily much the same as what I already did before. No, it isn't. It's different. Well, it's bloody different. But hey, this is the same. Bloop. Just copy everything. Okay, if the target is 0, then it's a p red. What p red? I'm talking about t is 0. The green is 0, and the red n red is 1. So we have the log. So I add the log of p red s, which is 1 minus the sigmoid. Call that A of activation. And otherwise we add, oh wait, there's a minus in front of it, so both cases must be minus. Otherwise you do the log of A. Where A is the sigmoid. If t equals 0, then n green is 0. So this does not count, so we use 1 times the log of p red, which is 1 minus p green, which is the sigma. 1 minus the sigma, yep. And otherwise we're going to end up with the sigma itself. So it looks good. Maybe A is a bit vague, let's use sigma. Well, we have to calculate the sigma still. The sigma is the sigmoid function. I think I have that. I have a function called sigmoid, right? Of course I do. Yep. The sigmoid of the in product of V and X, W and X. So, and that's called Z. So I have to do a double Z. Actually my sigmoid takes a float type. Let's use that. Returns a float type as well. And then we might as well use float types with that. And I'm not going to use M, get M. Okay, so I'll have to calculate Z now. No, it's no. My sigma is Z. Let's call it Z. And this I call V. Got to keep using the same variables, otherwise it's so confusing. Now V is then W times X. I guess that's just a contract. Contract W and X. Of J, J. That one's definitely new. No, not. Well, actually, no. No, that's not how it works. Let me see. I think I'm just going to write it out. So it's W0, J. No, of course not. W0, 0 times X0, J. I think the J is the second one. Here I'm calculating it. V, this is just a full tensor multiplication between W and X, including all the samples. So I could just use V0J actually. Already have it calculated. If we are still inside the scope. Seems we are. V is available. No need to calculate it again then. So this is V0, J. And I hate to declare something and then only use it once. So I just do this. Might be confusing that I'm using S here as S for sample, and then here I refuse to do that. At the very least add a comment in. Need more precision. What's this printed so imprecise? Don't get it. Oh, no precision in the code. Keep forgetting that. One more last time. It doesn't know that I asked it 5 times already before. It is going down. Tja. And these two. This one is going up and 10 down. And this one is going also down, and this is down because it's negative. But then it goes up, which isn't crazy. Also hardly changing. So sometimes we had, I think the first one here, is my guess for the loss function, which might be wrong. And it's going down in this case. So I think that this W is negative, then it goes up, which is really weird. Definitely going down. And one that we just added, the minus log likeliness, is also going down, although not very fast. Not very fast at all. Am I doing too many things or what? $100, maybe too many. A little bit less. Yeah, I stopped saying which season it is because this one is very positive, and then it definitely goes down. And that's with a negative value for W. And this one, though, goes really down. It's not even moving anymore. How is this loss function going down without me seeing anything? Is it going back, drawing here or something? Nah. I feel like drawing these in a graph because you can't follow what they're doing. On the other hand, in a graph you won't see what it's doing either, because it's just -2 then. This one is still going down. Yep, we should re-implement that refreshes the whole graph every 10 lines, because you can't see anything now. I don't know where it is wrong. If you see the green lines here, it's like a lens shape, going to a horizon. Ding, 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 ding. So it should be drawing at the horizon, I would say. And then this blue is here and red is there probably. Or from here to there, I think. So red is here. Really don't see the differences. It's Not even a single pixel is changing. Ah, I see a pixel changing. It's drawing this way, so the red is here, this way. Red is going towards blue. So what this means is that this value going down with the minus sign in front of it means that the log is a negative value which goes up, and going up means that the likeliness, which is much less than 0, that's why it's a negative, is going up. Yeah. So this is going up, then this is going down, and the likeliness is going up. And of course, the more likely the prediction is with the given training data, the better the fit is, I would say. I think we're done. No, it's not. It's just hanging. That's strange. Control C then. It's so slow. It's still amazing me. See now, the blue line is perfectly separating green and red. And that means, in my opinion, that it should contract the green and the red towards it until it's 100% sure. And that will continue until every point is like a few standard deviations away. So this point, these 2 points, they should still be influencing the width, making it go down, making it smaller and smaller. And by the time it is infinitely thin, so it's like a step function, it's 100% sure that this is green all the way up till there, and then it's 100% sure that everything on this side is red. It's a step function. It's like green, bang, or the other way around. Red, bang, up to certainty that's green. And that means that my loss function should go to 0, like really 0. Now this one seems to be going to really 0, 0.039. This one of anything but 0. That one is also going to 0, but if it is going to 0, then it's going up, which is really weird. but also nice, because that means that this is indeed not a loss function. So we invented a new loss function. So I think this is a loss function that I created that where I made a mistake. This is the cross, what the hell, how's it called? Something with cross. The cross entropy. So commonly used in machine learning, such as the binary cross entropy, the mean squared error or hinge loss. Where it bears some resemblance with a modified form of the log loss. So it's something else again. Which typically the loss function of the binary classification is given as. Anyway, that's that value. And that is going towards 0, which means it's going up because it is negative. So that cannot be the real loss function. It would never do that. Oh wait, I'm confusing the slope. This is my bug thingy, damn it. This is the existing one. That is going down. Damn it. Okay, it is going down. In fact, looks like pretty damn fucking the same as this one. Yeah, it's the same. Not exactly, but it's close the same. These digits are the same, and then it starts changing. But not so, again, frozen. What? Let's print it on a separate line. Let's change the meaning of L1. Make this the minus and this the plus. Or maybe just print L1 divided by my value here behind it. Now see how equal that is. Wow. And it's hovering around 1, so it's sometimes above it, sometimes below it. Is that also the case when we are far off yet? Let's go even slower. Yeah, from the very start. Almost the same thing. And is that every time the case? I mean, if it's even for this one, then it's the same thing. More or less, more or less. But more or less. Not already. Then 4 digits. Immediately afterwards 7 digits. After one epoch. Yeah, that one was rotating all over the place and still so many digits the same. Interesting. Okay, well, I think that means that I really must have made a mistake for L2. And I should be able to find it if there is a mistake. The difference is that my L2 has a plus here, which comes from the minus sign in front of it and then a minus sign here instead of a plus. And that was derived in this readme, the bottom. Here we have the minus sign in front of it, and here's the minus sign in the middle. Where does that come from? It's supposed to be the derivative, partial derivative of L with respect to a given sample. Well, if you take the derivative of this, a partial derivative of CZ, and you're summing over all the samples, then of course all the derivatives are zero except the term with ZS itself. So we have to take the derivative of wherever ZS is equal to the thing that we are differentiating to, from, over, against. I don't know. Which depends on the value of t, because if t is 0, then sorry, derivative is 0. Derivative of 0 is 0. And that means that if t is 0, then we have a minus dropping away against a minus. 1 minus 0 is 1. That's a constant. And the derivative of the log of 1 minus z is 1 over 1 minus z. O times minus 1. We found the error. That was fast. Haha. Yeah. Just a one-liner. Sorry, but this has to be a plus. Yep, for t is 0, this must be the derivative, which therefore comes from the log of what is under here. And then if you take the derivative of the log, you get 1 over what is in the log times the derivative what is inside the log, which is minus 1. Oh, wait a minute. Oh yeah, and that's that, -1. Pew. Yeah. So that's correct. This -1 drops away again, that -1, or the other way around. So we get to plus this. And for t is 1, we have simply this one. This is 1 over z, with a minus in front of it. Okay, I'm glad I found that one. Okay, let's ask again for the name of it. What is the name of this loss function that you also mentioned? Above. No, that is the binary cross entropy loss. Yep. Well, I derived that myself. I'm proud of it. Yeah, cool. I know. Well, or maybe they derived it in a different way. I don't know. You're not allowed to see this. No, this is just cross entropy, not the loss function. Cool. No. Well, it is still not finished, I think, because I still think it's very slow. Let's see, so this is L1 is the delete L2. Okay, I think that I already see the difference, right? I mean, it's just exactly the same, except that, so for 0 we subtract the log of 1 minus z, and that's what we do here. So the difference is that this z is calculated with doubles, and the other one is calculated with a long double. So it's just a round-off error. They're exactly the same thing. My activation function is using float type as well. This is just sigmoid. That should work. I don't see the difference really. It's kind of weird that it's not exactly the same. Right, because now suddenly I'm not using double anymore. Oh, here I'm. Yeah, just float type here then. As well. Now I don't see a difference anymore, so now it should be exactly the same. It's not the same. What the hell, man? Why? It's so weird. L1 is a float type. I run over all points. We check T. And I'm using Z. And standard lock. And here, L is also a float type. We also run over all points. We also use T. And we also use standard lock. So the only difference is that this Z is a float type that was calculated from V through a sigmoid, and this one is using Z, which is using the activation function, which is using a function that is the same as a sigmoid, isn't it? I mean, sigmoid is definitely using float type as well. Applied to, I could use activation itself here again instead of sigmoid, and at least we have the same function. This one works on all elements of V, which is calculated from W times X. And my V comes from the same V. But yeah, totally. The exact same V is being used even. So the only difference I can find then is that I'm using sigmoid here instead of activation. Now activation is a function. I need to call the thing inside of it then. This function. Float type. This is the one that I was using, so this is also float type. It's the exact same thing. I don't know, what is float type then? A float, okay. Definitely found a difference there. That's very inaccurate. Yeah, okay. So, problem is with the float type here. Okay. My functions are using a float type. What the hell? My tensors are using float type. Ridiculous. Okay, so let's, I don't know, what did I change? Tensor is already, no, yeah, it's already a template. So why not pass the float type as well? Yeah, okay. Change this into long double. And then it will be 1. No, whatever. Okay. Still get to see the difference. Yeah. So what is next, man? That's pretty weird. So yeah, I would like to understand this, and by seeing how it jumps around in this loss function, how do you call that? Doll. A valley, yeah, of course. So it would be nice to have a graph where you see the loss function with its minimum, and it's called a valley, and then see how it jump around in that, you know, instead of going to the bottom door, because it's erratic. And we can plot that because we can just simply plot the loss function as function of well, whatever determines the slope. I think we should use well, basically there are two of them. The slope is the, do you see the slope goes all over the place? Both of these are changing. I think the slope is 1 divided by the other. The bias is stable. It's already two-dimensional then. I mean, I can plot it against the slope, but I want to plot against just one of the weights. Theoretically still possible. You can draw a three-dimensional plot. So a weight like this and a weight like this, and then a loss function vertically. In this case that would be sufficient. No, the bias changes as well a little bit. Definitely keeps changing. What happens if I pin the bias? Do we not already started this value? I think I should started it. It's already off. Yeah, but I think we started it. Ooh, that's so much off. Unbelievable. What the hell, man? So I set the gradient of the bias to 0, so we don't change the bias, right? See what happens then. Then it becomes three-dimensional, so at least theoretically we can. It's still unstable, very good. And does this not change? Indeed, it does not change. Very good. Yeah. If I pin the another one, if I pin, say, this one as well, then it's probably stable. I mean, come on. Yeah, it's stable, right? That is stable, and if you pin the other one, the last one, instead, so we do W1. Oh, nice. Totally unstable. So W0 is unstable. I can even make a normal graph then. See what happens. Yes, let's do that. See if we go to 0.1, if then it becomes stable. Ooh, even then it's not stable. Not really. Yeah, no, it is. No, it's not. See how this jumps between 0.05 and 0.11. That's huge. But it's stable in the sense that it keeps jumping between the same line, so you don't see the change. It's definitely jumping. So this is super interesting to see. Oh, methinks still. Right, so now what I want is to draw a graph of horizontally the W values, W0 values, and vertically the loss. Without doing any epoch at all. Hello. Yeah, it's totally live. Let's see. not updating the weight, not I still have to do this. I'll see it in the git diff, I guess. I commented this out. So I enter in here. Oh no, this is a calculation of the loss function. I don't need that. Oh, I do, but I should make a separate function of it. I don't want to draw this. So really, we can go down with the if, not this, not this. This can be deleted. That's another loss function. We don't print anything, we don't sleep. This is that, and we got here, so that's the end of the for loop, and I don't need a for loop, so we can do a break here. And then at this point, I can make a loop that changes the W 0 value, which I can do because I have a reference to it. So let's say I just use my float type. We call this delta W0, which runs from, let's see, the value is about this, so jump, let's say, nah, I don't know, start with -1 till 1, I think. What's the value? What has the values been? Very small. Okay, -1/2 to -1/4 till -1/4 till +1/4. Actually, it's always positive here. Oh, the delta, yeah, okay. Let's do -1/4 till +1/4 to begin with. And then we do that in steps of 100th. Just try something. I need to remember the old W0 value as well. To the correct value is W00. And then we are setting it to that value plus the delta. And then I want to calculate my loss function. Just use this. But that doesn't work because I'm using V. I have to recalculate V because W was changed. V is contract WX. X is not changing, that's the training data. T either. but got to recalculate V. And then we calculate the loss function, and then I want to draw a graph of the W value against the loss function. I think that has to be done with two vectors, of doubles. The axis and the y values. I'm just going to push back this. And the y's is then my L. And then we have to make a drawing of it, well, at the end anyway, here. Well, probably something that used that axis. I did not use that before. Dude, why not? No, maybe not. Whoa. I thought I did that, use the same name before. No, I don't know anymore. Or at least maybe just that's still the same thing. It is called Y's. Why don't I have I don't have X's, but I do have Y's. This is an array though. To be able to learn from that how to do it. No, like that, I guess. Oh, that's why I call it like that. Okay, and then in this case it would be single S because it's not an array. Let's try to be consistent. X data, Y data, X size, and then some title. What is the title? I want my subscript. Subscript W0. Let's see if GNU-plot can show that. What? I think it's this. It's drawing it as a green shit in the same graph. No, I did not want that at all. How do I reset that thing? I think I have a reset written. It doesn't look like it at all. Reset graph. X. GNU-plot reset plot. Reset plot H1. I'm just gonna brute force resetting the whole thing. No, that so did not work. Okay, then we'll make a complete new one then. H1 is H2. Draw it, wait for the return, or just wait there. Why wait there? Should have two windows now. Yeah, there it is. This is our loss function. As function of no, that looks nice too. I think I want to smaller steps, maybe 4 times more. And starting at 0 is probably enough. From here maybe. From here to 0.2. Looks asymmetrical. Minus 0.5 to 0.22. I've got it again. Oh, minus 0. Yeah, 0.05. Is this what I wanted? No. Because it's not delta. It's like the bloody graph changed. So if we make this very small, yeah, nonsense. Yeah, good enough, I guess. Now I want to make it a line style. Nobody knows how that worked. Something with quote line, maybe? Nope. How about line anyway? Probably have too many of those. I'm not drawing lines in this thing. Let's just grab for quote line. Probably somewhere else. No. Lines, line points which didn't work, I think. It's lines, that's what it is. Can you put set style lines? That's what it is. Good. And now we want to draw inside of that. Let's begin with a single point, namely maybe this thing that I have already supports it. Let's have a quick look. could just use this. Pass an n of 1. Yeah, let's do that. So we just pass null pointer, we get no title, which is apparently what I want, or not really. We want no title. Maybe that one works as well, though, but don't believe it. What? I'm believing ChatGPT over existing code. No, I have to test it like this. I just test it like this. Really. So that thingy. Using H2, of course. Didn't close H2 yet, did I? No, didn't. Never close it. X. My X is a pointer to. It must be a double. Pointer to X then. Pointer to Y. Only 1 point, and this is a null pointer. Double X is the current value of W0, and the Y value is my loss function. Oh, fuck. Fuck. Even that doesn't work. Oh wait, it's under here. Well, it's crashing. Dude. I don't see anything being drawn at all. And as you can see, the no title did not work. Did so not work. Oh, and that also doesn't work. Fuck. Why are we not seeing anything? What am I trying to draw anyway? I close it again. Damn it, man. I don't think the 11 fits. Loss function is it's 13, 12. But how is that possible? Oh, it's no. It's my mouse. Hold up. Yeah, that does exist. 12, 13, 12. It's just not drawing anything. There we are. And you see immediately what is happening. It jumps back and forward. But nobody understands why it is not exactly on the curve. What the hell? Why? Why me? I go to bed because it's getting too late. Yep. Oh, because W is updated after calculation of V. Ouch. I shouldn't use V for the calculation of the loss function. Should not, ever. Bad things happen when you do that. So this is not good. It's the only place that is not good. Really. The new code is not good. Calculating it here as well, but apparently in a different way. It's using Z, as if Z is calculated, recalculated. Also not the case. So this is giving me the loss not of V. Not of this W, I mean. WWW. Hello, Bedreddin. The good old times when you could just use Carlo and then you had that name. These times apparently you have to type in half the alphabet before the username is not used. Although I think on YouTube you can type whatever you want, right? Even if it is a duplicate? No? I need to write a function that calculates the loss of the current W No, this is sorry. Can put this at the end. So we just calculate the loss here, period, of the current W before changing it. G is already calculated. Yeah, and I can't apply it already. Yeah, so this L, it's just the L, which just plot. Yeah, now we are on the curve anyway. I think that the insane thing is why are we crashing anyway? Strange. GNU plot coordinates title. Oh. There we are, no title. I want to know why I record them. Sorry guys, I just want to know it. Looks like a string problem. String copy handle 2. GNU plot coordinates is wrong as usual. Name is a file name. What the hell is this, man? Oh, well, way too big. You can't do that. Why is it so big? ntimp. I guess I overran a limited array size or something like that. Too many temp files. Well, shit happens. Cleanup is non-existent. Oh. It's not even that much. Remove temp / plot. I think we crash anyway. Okay, so what is next? Oh, you did not see this. Didn't clear. Never show random directories. Yeah. No. So basically we're making way too huge jumps there. Completely past the bottom. Well, completely. If I divide it by 2, it's actually already pretty accurate. I can't even find it back. So it's something with g equals. No, more like where we use the g. So moved here. What about half the size? I mean, that should still not work. Maybe it does, but I'm very curious what that is. Fuck off. I think it's still jumping back and forth. What? Definitely still jumping back and forth. How is that possible? How is that possible? That's something really strange is going on. Let's make some really small steps. I can find a make. That's the last time because yeah, now we're talking. That's what I call gradient descent. That's totally at the bottom here. Blinking at the bottom. Could write a book about it. Blinking at the bottom. Machine learning in 2023. Right, I remember. I wanted to close H1 like a rapido, so I don't, it doesn't bother me anymore. And it's not closed. It's not closed. Of course it's not closed. We don't get there. And you should not draw to H1 at all, which means don't call that. It's sticking up a middle finger to me now. Yeah, that is totally not what I meant. Well, that's one of them, and then we have another one, which is up here. Now, what should we go to? Nope, still the middle finger. So also a draw, man. I need a plot. Here's the plot. H1 is returned with a plot. Can you imagine? Don't even have an H1 now. Can't close it. There we are. Gradient descent. So nice. I love to see this. Still got them, but now what we can do is let's say look at the other one. So I keep that one constant, and we draw the other one. So now we get to see the gradient descent of the W1. Probably not working at all because my boundaries are wrong. It's interesting. Definitely blinking at the bottom here. BATP. Yeah, can't pronounce that. I think it was nice, except of course that we draw the lines of the wrong thing. Lines, 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 there's lines. Here's lines, and we're drawing the data of the wrong thing. Not to mention that this is just wrong, and this is wrong, and everything is wrong. No. So W1 is that. That's the only one that changes. And then we do the delta on it. Change the right one. And that's it, I think. Yeah. Yep, nice. The gradient descent. And then of course the last one, which is the bias. So now I have to make it work for everything. And then all three at the same time. Yeah, of course. All three at the same time. How would I do that? Well, you make a for loop. Int j equals 0. J less than or equal to plus j. I'm using j already, damn it. Okay, I'm just going to change this j in s because that's what it is. Fuck the scaling factor. For plot. J, 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 V, L, S. Do you want to do S? There's nothing that we need to change anymore except this one. J, and then we plot that 3 times. And the title is, oh really, standard O stream. There must be an easier way than this. String stream title. L as functional W J. Title dot string dot C string. Okay, we have this, and then I want to also draw that. So I'm gonna rename this to S as well now, because this just runs over the samples. Yeah, that's not working. And I need to do the whole thing 3 times, I think. Yeah, it's not working. I'm only changing a single W element, single weight, and then we calculate a loss for that, and then I'm printing it everywhere. That's nonsense. Let's just change all of them, see what happens. I don't know. I have to go to bed anyway. Why is H2 not defined anymore? Oh, I put it in a loop. It's all so confusing. So yeah, that was bullshit. It was the same Y value everywhere. But I did get all three, yeah, kind of. The width is wrong. The delta values are wrong. I need 3 different delta values for the 3 different J values. Where's my delta? So depending on J, we need different delta values. Which are just guesses, I guess. Can you imagine a guessed guess? It's like, yeah, bedtime. And before I go to bed, because I'm an idiot, I'll play a game of chess. Yay! Hey, we can challenge people by too late. 3-1. Let's do it. 3 minutes, nothing. But you get 1 whole second to move, so try not to get out of. Oh, yeah, this guy already moved. I lost so many seconds. Not going to take. Next ball. Yep. Just not doing it. It's kind of annoying. Also annoying. Especially because I have to go back, I think. He's blocking. Why the hell not take with the queen? Ridiculous. I push this, yeah, that's the why not move. And then this he takes, I take, and I lose my queen, so I go here. That's a silly move. I want to play this anyway. Now I can do this, he takes, I take, and then, I don't know, pins it. Let's begin with that. Oh boy, this guy is annoying. He wants to play that. Nah. He's playing on tricks. Tricks over kids, they said, so it's probably a kid. Why did you not just push my pawn? Now it was possible. Was it one time there? Or? Check. This guy, he takes, I take, I cannot take. Let's put this here. I'm kind of threatening to push. I'm gonna go here, I think. Then put my rook here. Haha, you thought I was going to push in the center? No, 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 no. Going to smash you in the center after you move all the rooks to the side. I push, he takes, I take, he takes. It's not good. I need a rook here. There's simply no pushing the center pawn. So instead, I'll just take here, he takes, I take with the queen. And I win a pawn. Why didn't I do that immediately? I don't think that's doing anything, except that he's going to put the rook behind it. Maybe push now. He take, I take, he takes. No, not good. Let's take here. And then here. Then defend against that bloody mate. You can still take there. That's kind of annoying though. Yep, and now let's go to the side, because that pin there, I don't like it. This is not good, especially not my time. Can't blame the guy. I'm totally losing on time here, am I not? No, you have to go there or something. Five seconds left. He's going to, I don't know what he is doing. Give away stuff. He thinks I win on time against Carlo. I just exchanged everything and you're dead. Oops, damn it, that was the wrong button. This guy got lucky. I lost some time there, it's unbelievable. What an asshole! And the next 8 hours I can't sleep. I hate chess. Why am I playing 3-1? Ridiculous. Okay.